All right. So just just before we get into working out the solution of this, I want to just go over a couple rules with respect to this. Okay. We have a couple rules basically. I don't like yellow to write with rules. All right. So we know that there are certain things that we can't do, right? You can't have an entity like entity one and entity two in a system. You can't have direct data passing from one entity to another. This is wrong. All right. So just look out for that. You also can't have an entity having a direct relationship with a data store. Okay. So this is these two examples, right? Um, these two examples here. This first example is like if it is that you were using the bank system to transfer, let's say Chelsea had money for Jasmine, and Chelsea gave Jasmine her money in her hand. Would the bank have any record of that? No, because there is no instance of any transaction taking place between the two persons. Now, both Chelsea and Jasmine might have an account with the bank. But if Chelsea puts money directly into Jasmine's hand, then there is no record in the bank of money moving from Chelsea's possession to Jasmine's possession. Now, if Chelsea used the internet banking, then the input that Chelsea would have put into the system would have been the amount that you want to transfer and to whom, and the output that she'd get is whether the transfer was successful or not. The same thing would happen on Jasmine's side. Jasmine would get a notification that $200 was transferred to her account. And that now would look something like this, right? Where you have the system and you have Jasmine getting an output of the system, Chelsea putting her input and getting a receipt from the system, right? So this is the bank system. You understand? But if it is that we have two entities directly interacting with each other, then there's no record of it on the system, and the system becomes redundant in this case. So there should be and what we're doing is that we're modeling interaction with the system. The system cannot control or record interactions that it can't keep any track of. Okay? The same with an entity and a data store. I would love to walk into the bank and change the value in my bank account and add about 4 or 5 extra zeros after the sorry, before the decimal point. Okay, right? And if I have the opportunity to and the bank will honor that, then I will probably retire from teaching the following day. But I cannot interact directly with any of the data stores inside of the bank. That'll, for just the reason that I spoke about right just now, it'll be a violation. So an entity cannot in any way interact directly with a data store, right? Yeah, Joshua, that's probably why I can't do it. Just for the fact that this class would miss me. Probably next year I'll be able to go into the bank and just add a bunch of extra zeros. All right. Or we also have let's say for instance, at no point in an entity relationship diagram should a process interacting with another process or a data store or an entity have anything like this. That's a violation of the system. Okay? the data always flows in one direction. So these are violations. So if it is that you have anything that looks similar to that right now, we're going to have to work around that and fix it. Okay? But be mindful that we are learning. So, we will make little errors like this ever so often. Right? Anybody has any questions on any of these violations that we might encounter? Right. Same thing, Josiah, a data store cannot interact directly with a data store. Okay. Again, it only through a process should a data store have any interaction. So a data store, let's say for instance, you have a loans account, right? And you have the savings account. We don't want any interaction between data stores without a process being involved, because data must be processed. Data must be processed. Okay? So you can't just simply, even the fact that you're copying a value from one data store to another data store is a process. So for a value to move from one data store to another data store, for a value to move from one data store to another data store, it must pass through some process which validates the interaction. For Joshua's sake, I'm repeating the first one. Okay? Two entities within a system cannot directly interact with each other on the model because that is not something that is under the control of the system. Okay? It come like if you're running a Susu and you are the person in charge of the Susu. And David give me it's David month to collect, right? So Chelsea give me money for David, Sachin give me money for David, Joshua give me money for David. But Josiah decided to put the money directly in David's hand. I, as the bookkeeper, could say, okay, well, I receive money from Chelsea, I receive money from Joshua, I receive money from Sachin. I can't vouch for Josiah. Because unless David come and tell me, well, yes, Josiah really came and gave it to him, I don't have any record of of Josiah giving the money to David. Okay, so David could come back now and say, well, Josiah never give me any money, and I keep the records. I don't have any record of Josiah. Josiah, where your receipt saying you give the money for the Susu this month for David, right? So that is why it has to come that Josiah would have to come to me. I am the process. I record the transaction, and then I can make the payout to David. Josiah, that clear it up for you?
Yes, it comes.
Right, and also Joshua.
Yes, it has an explanation.
All right. So we now aware of the rules. Okay. Think about it like this. Almost everything must happen through a process. All right. And the reason that it has to happen through a process is because part of processing is recording, is having that transaction log to say, okay, the data reached to this point. We have a record of it, right? Or at least we have a record of it being, processed. And maybe it might be stored for long-term storage. But we have a log, we have a way of keeping it. So we're jumping back to this question. And we're going to take a look at it from a context level. Okay, so we're looking at this question from a context level. We say New Smiles is a doctor's office operating in the busy town of Happyville. Patients, okay, so I highlighting in yellow any external entities. Patients book, why this thing not dragging? Appointments in advance. Oh, and now it's working. To see Dr. Sam. a patient calls into the office to request an appointment. So the patient has to first check to see if it have an appointment. The receptionist asks for the person's name to check whether their patient record already exists in the patient's database. If the record does not exist, a new patient record must be created using the database, using the following information gathered from the patient. Okay, and we have the name, the telephone number, address, and the brief history. On completion of this standard procedure, the receptionist books the appointment. That is, the patient submits a preferred date or time. Now, anybody here thinks that the receptionist is an external entity? You could put your hand up.
So you could repeat the question.
Does anyone here think that the receptionist is an external entity? Okay, so nobody. Everybody understands that the receptionist is part of the system. Okay, because the receptionist is actually the one carrying out some processes. All right, so the patient submits a preferred date or time. The receptionist checks the appointment database for available dates or time and schedules a suitable appointment based on this. The scheduled appointment is returned to the patient. Finally, every day, the receptionist calls the patient one day before the appointment to provide them with a reminder. A list of upcoming appointments is generated from the appointment database to facilitate this. Now, all we're looking at right now is to see what going into the system. Red will be going into the system and blue will be coming out of the system, data going in. All right? So the patient will book the appointment. So that's a red. Okay, so the patient will call into the office to request an appointment. So that booking or that request for an appointment is red. The receptionist asks for the person's name and then the system will check to see if it's in the database. If the record doesn't exist, then the patient has to put in this information here. On completion of this procedure, the receptionist books the appointment. That is, the patient submits a preferred date or time. So the patient has to say when they want the date or time for the appointment, right? And what they will get from the system is that the appointment will be scheduled based on that. Okay, so that scheduled appointment is coming out to the user. Every day, the receptionist calls patients one day before the appointment. So that notification call, that notification is something coming out to the patient. Okay, this list of upcoming appointments is something that is inside of the system. So if it is that I am drawing this system as a context level diagram, okay, so we have New Smiles appointment system. And we have the patient as the only external entity, ATIENT. The patient puts information into the system, and just for conciseness, right, I will put personal info, and the patient will also put in the date and time for the appointment. Okay? Coming out of the system to the patient is the appointment date and the notification. I'll call it a reminder notification. Okay? So I'll call it a reminder notification. And remember, you're not really obsessed with the call. You're more obsessed with the data that it represents. So put in name, telephone number, address, medical history, right? So let me include medical history separate. Patient personal information and medical history, right? Because personal information is that name, telephone, address, number. The medical history is the medical history, what you come into the dentist or doctor for, sorry. And the date, time, right, for appointment, your availability. That is what I'm telling them. And I'm getting, okay, yes, this appointment date works, so no, this appointment date wouldn't work, and then you have to give a different date or time. But we're making the assumption that once you give your date or time, we're keeping the system simple. So once you put in your date or time, you get your appointment date and you get that reminder notification a day before your appointment. Now we're going to see how the system will break apart now into different little processes that make this whole system available. But could everybody see how this context level diagram works? Yes. Yeah?
Yeah.
Right? I see Joshua asked a question, if what was external, Joshua?
So it'd be, I think the receptionist.
In this case, the receptionist cannot be external. The receptionist is part of the system. So in the last one, there was the possibility of a warehouse being external, because a warehouse, it might be that the system interacts with an external warehouse because the warehouse is actually its own repository of data, right? We rationalized how that in that case, the warehouse was not. But there are some cases where the warehouse could be. In this instance, the receptionist cannot be an external entity because the doctor cannot have an external entity accessing parts of the system that are sensitive. So the receptionist is like a living process. The receptionist is the one who actually, in this case, processes the data, right, into, or changes the data of the request into the actual appointment. And that we see that, and this makes sense because we know for a fact that we can use a system like this to represent a manual system or an automated system. So in this case, we are actually creating a data flow diagram that represents what this manual system looks like, where this receptionist records the information manually. Okay, the receptionist receives the call and then enters it into the doctor's computer. And every morning on the doctor's computer, the receptionist will get this list of persons whose appointment is for tomorrow, and that receptionist will call them. Right? That actually happened to me today because I have a dentist appointment sometime tomorrow, and I received a call from the dentist first thing this morning. Say, hey, Mr. Valdez, the appointment is tomorrow. Okay? So that's how the system works. Right? That they just store it in, but I know for a fact my dentists don't even have a computer. They write everything in a book. Okay? But they have their system worked out nice and proper. All right? But this is something that you can look at and see, and I'm glad that it's semi manual in this case, because this is somewhat like what your SBA, something like what your SBA might be looking to resolve. Okay. All right. So are we ready to take a look at the data flow diagram, the development of the data flow diagram? All right, nobody's screaming. Yes, yes, sir. Let's go. No.
Yes, yes, yes. Let's go. Yes.
Thank you, Shivan. All right, that's all I wanted to know. One person, but no, you all have to give like an awkward pause to make Mr. Falder seem like a mad person. All right, who gets this excited over data flow diagrams? All right, but thank you, Shivan, for filling that gap and making me not that one crazy guy who just seems to be all out and ready to do data flow diagrams. All right, so we have the next one, New Smiles. New Smiles is a doctor's office, right? We starting over, right? Yeah, I think people should give like Shivan a little applause or something. So all right. No applauses for Shivan. Wow.
I think we should give our applause for Sir at this point.
I don't need no applause. I salty. I just Are they breaking me? Are they doing it to me, boy? All right. I get like one applause from the same guy who was excited to go forward. All right. That's okay. All right. Okay, so we have the New Smiles doctor's office. We have our patient. We know that our patient is our external entity. We established that in our context diagram. Okay. The patient calls into the office to request an appointment. So this is something that the patient is interacting with. The patient is interacting with the first process, right? So this first process here, okay, one could be the appointment booking process. And let me let you all know something here. There is no one correct way to generate a DFT. Somebody might look at a statement and see two processes. Somebody might look at a statement and see one process. In both cases, they can be it could be correct in most cases that you could look at something and see one process doing the two things, or you could look at something and see two processes and doing one thing each. Okay, so it's not that if it is that you don't have exactly what I have, that what you have is incorrect. And if you want a little analysis or a little feedback on what you may have developed, you could always just shoot me a message and say, this is what I drew, right? Let's talk and see if we can find out whether this is correct or not. All right, or where may I have gone wrong, or is this correct enough? All right. So typically a patient calls into the office to request an appointment. So the receptionist asks for the patient's name. So we know that the first thing that goes into the appointment booking process is a name. Okay. And the appointment booking process will check to see whether that record already exists in the patient database. So we have a patient database. All right, 2. Now, there is a somewhat lazy way to do something. You could always know that, of course, if that appointment booking process requests something from the patient database, it will eventually pull that patient info, right? You notice that I did not put the line with the request for the patient info coming from the patient database. Because if I'm pulling information from the patient info, pulling patient info from the patient database, it is assumed that the request was sent. Now you could draw the request if you want, okay, but sometimes when you're looking at it, you might just see no request sent, but information coming from the database. What in that case, it's just assumed that the request was sent, right? So patient info request. So we get the patient information, right? And if that patient, however, does not exist, we must create a record in the database gathered with information gathered from the patient. So if the patient information didn't exist, we take their personal info, and we have a new patient creation record. You all understand what I did here? Does anybody not understand what I did here? Okay. So notice that this is not a flow chart. This doesn't tell me the order in which things happen when I read it, right? So the patient passes the name and personal info. The patient information is requested. The patient information is sent back. But if there was no patient information sent back and this information was passed, then the new patient would be created. But there is no way to see that in a step-by-step manner. This is just modeling how data flows through the system. Are you with me, my students?
Yes, sir.
Yes, sir. Yeah.
Like two persons responded. This is this is cause for celebration. All right, you all may get your ice cream yet. Okay. All right. I mean, granted that you show up on the day for the ice cream, but we'll cross that bridge when we get there. Okay. And of course, we had to put in the medical history as well. How could I forget the medical history? Medical history. So on completion of this standard procedure, the receptionist books the appointment. That is, the patient submits a preferred date and time, right? The patient submits a preferred date and time, and the receptionist checks the appointment database for available times, right? So your appointment, you know what? Let me change the name of this from appointment booking to simply appointment request process. Okay, so I'm just changing that. We're making a second process named appointment booking. So this is where the actual booking will get done. Appointment booking process. Okay, so we have the appointment request where we could verify that the patient exists, or if the patient did not exist, we will create a new patient. Once we could verify or create a new patient to ensure that their data is inside of that patient database, now we could get into the actual booking of the appointment. Okay? So we pass that verified patient info. We pass that verified patient information into the appointment booking process, and what is required from the patient is that the patient submits a preferred date or time. And we have to check the appointment database. So the patient puts in their appointment date / time. And now we have, why did I label that first one 2? All right, that's okay. I can label this 3. The labels, it really don't matter. Kind of. All right. So this is the appointment database. The appointment database, and we have the patient information who is verified that we have some data about them. and the patient submits a preferred date or time, the receptionist checks the appointment database for available dates or time. So again, we could do that whole thing where we just get available dates / time, okay, under the assumption that we've requested it, and we schedule a suitable appointment based on this. And the scheduled appointment is also returned to the patient. So what do? What we do is once we have that available date and time and the appointment requested date and time from the patient, right? We have confirmed patient appointment time. And this goes to the appointment database. And I'm going to do some, let me not be lazy. All right, I was going to kind of just branch it off and send it here, but I don't want to be lazy and do something incorrect. All right. Confirmed appointment time back to the patient. So now in these two processes, we managed to save the patient information through the appointment requesting process and book the appointment in the appointment booking process. But now every day the receptionist calls patients one day before their appointment to provide them with a reminder, right? So a list of upcoming appointments is generated from the appointment database to facilitate this. So we have a third process called appointment notification process, and it pulls information from the appointment database, right? So this is upcoming appointments. It pulls information from the appointment database and it sends a notification to the patient about their upcoming appointment. So, upcoming appointment notification. And this is it. This is the DFD, the level 0 or first level diagram. And if we go back to our context, it matches up essentially with what was sent into the system, the personal info, the medical history, the date and time, and the appointment date and the reminder notification. Right? We have the personal info, the medical history, the appointment date. We have the confirmed appointment time and the upcoming appointment notification. Right? So this is the confirmed, right? So confirmed appointment date and reminder notification. Any questions? Is this vastly different from what we developed on our own? Josiah?
So, I had the right idea, but I think I just overthink a little bit. So, like, it was looking similar at the start, and then it just went up there halfway through. It's just,
Okay,
I think what is the problem is like, how you just come, I find you just come up with names like really easily, and I be struggling with names. I think that's my problem.
Okay. So the processes can be you know, it's essentially a verb about what you're doing, right? So we have a request, a booking, a notification. The data lines normally have nouns on them. Okay, we only have nouns. The data lines are not verbs at all. all right, except in the case like up here where we make the request, but then you notice the important part is still a verb. It's just patient information. Okay? And of course, the external entities are normally defined in the specification itself. That should help a little bit. So, you know, the verb and the noun thing, if it's doing something, then it's more than likely a process. Yeah, but I mean, don't separate a process just to send data. If like Josiah, if you have a process that is sending information to another process and all that process is doing is updating a database, then the process that initiated that request could send the database, right? So a database update or a notification, right? Well, in this case, the notification pulls from this database and sends here. So this notification is its own process, right? Because notifications typically have to pull from a database and then send to the person. But if it is that, like in this case where you have this appointment request process, you don't want to take the information, then send that information to another process, which the only purpose of that process is to send it to the database, right? That process is redundant. You could let this process do that database update. David? David? I see your hand up.
Yeah, sorry, Sir Vincent. I just now spike. You hearing me?
Oh, yes, I'm hearing you now.
You could repeat again. Context level and level 0 is the same or it's different?
This is where CXC, sorry, computer science and IT diverges. For a long time, context level is said to be context level in computer science exams, and level 0 is the first level of the diagram. But a lot of books have context level and level 0 as the same thing. In most cases, CXC is looking for this first level, and they call it a level 0. I would say only draw a context and nothing else if it is that CXC says draw a context diagram. But once they say something different to that, draw level 0, then it is more than likely this that they are looking for. Does that answer your question?
So it's really the question itself that will determine what is your draw.
Yes, and if they say level 0, draw this first level diagram. I know that between IT and ComSci there's always that conflict, because IT says draw a context or draw a level 0. Sorry, you know, as the same thing, I believe, but computer science context is different from the level 0 according to what they say. Okay, but as it is right now, everything that I give you, draw both, because I want you to get the practice of doing this and then doing this. Any other question? Let me get my face in next to my.
So, I know you said that you could put more than one name on a data flow, but does it have a limit?
Yeah, I mean, you don't want to overload. If it is that you see how, like, instead of putting name, telephone number, address, brief medical history, I merged name, telephone number, address into personal information. If the data is related, then you can do that. If it is that you end up with a long list of unrelated items, then you might have to ask yourself, is it really the same process that is dealing with processing all of this different data. If you have a list of items on the data line, then you need to think there must be some relation between them. Okay? I really can't see, especially at this level, a long list of information being sent on the same data line that is unrelated but necessary for the same process. So if you have, a list, or even if you have 2 or 3 things, ask yourself, is this all related? If yes, then fine. If no, then you might have to think one of these things might need to go to another process. Any other questions?
So we send the DFD, send it on WhatsApp or on Teams?
No, send it on Teams, please. Send it in the Teams chat. It's a little easier for me to deal with this. WhatsApp mostly it comes to my phone, and I'm not very good at replying on the phone. All right, so reply via Teams, or request via Teams. Send it via Teams. Anything else? Can I stop recording? I'm going to. Okay.